In this video, we're going to use the triangle proportionality theorem and the triangle midsegment theorem to solve problems. So first, we're going to go over what the triangle proportionality theorem is. You'll notice it's written in that if-then format. If a line is parallel to one side of a triangle and intersects the other two sides in two distinct points, which happens here, BD is parallel to AE, then what happens is that segment separates the sides CA and CE into segments of proportional length. So we have several different proportions that we can use. We have parts here CB and CA is the whole, so we have part over whole. And then on the other side we would have part CD over the whole CE. So part to whole is proportional. We have BA and CA. So this piece here that's not the side of the triangle but the piece is proportional to the whole here, and DE would be then proportional to the whole CE as well. CB and BA. So CB is proportional to BA and CD is proportional to this piece DE. BA to DE, so we have the piece on one side that's proportional to the piece on the other side, is proportional to the wholes set up as a ratio, so CA and CE. So CA is the whole here, CE is the whole on this side. We notice here we have several ways to set up proportional parts. These aren't the only ways. We'll practice more in class on these. These are just a few examples of the proportional pieces we can set up. We also know some things about the angles. We know because BD and AE are parallel lines, we have angle 1 congruent to angle 4 and angle 2 congruent to angle 3 because of the corresponding angle postulate. We know those are corresponding angles when parallel lines are cut by that transversal. Okay, in example 1, we want to find the value of x, so we're going to use the triangle proportionality theorem. So I'm going to set up a proportion to solve this. One way I could set this up is to look at the pieces. So I have the piece that's x. Let me choose a different color. The piece that's x over the whole. The piece that's 8 over the whole. So I would set that up as x over x plus 1. That's the piece over the whole equals 8 over 10. I got 10 because I added the pieces 8 and 2 together to get the whole of 10. From here, you just solve the proportion. So you have 10x equals 8x plus 8. Then subtract 8x and get 2x equal to 8. Divide by 2, and x is 4. Okay, notice at the bottom I said set this problem up a different way and reach the same solution. So I want you to try and use one of those other setups of proportional parts to get the value of x. In this example, we want to find the value of x. We can use proportional pieces. So RS is to ST as PV is to VT. So I would set up that proportion. So I would have 3 over 5 plus x equals 4 over 8 plus x. Now that I have my proportion set up, I'm just going to solve by cross multiplying and solving the resulting algebraic equation. So 3 times 8 plus x is going to be 24 plus 3x equals, distribute the 4 times 5 plus x, so I get 20 plus 4x. subtract 3x on each side, and get 24 equals 20 plus x. Subtract 20, and get that x equals 4. Again, set it up a different way and reach the same solution. I want you guys to try example 3. In example 4, we're given if the measure of RT is 10, find the values of x and y. So we know that the entire segment RT is 10. So we know 6 plus y has to equal 10 units. So 6 plus what equals 10? So now we know y is equal to 4. Now I'm going to use proportional parts to set up and solve for x. I could use the piece RS and RT, so the part to the whole, and then RS corresponds to PV over the whole. So I can use those pieces to set up a proportion to solve for x. So I'm going to have 6 over 10 equal to 9 over the whole. Now, just the same way 6 plus 4 gives me a whole segment of 10, the whole segment PT is 9 plus 2x minus 1. So I'm going to add those two together to get the whole segment. So 2x minus 1 plus 9 is 2x plus 8. That's a plus. Now I'm going to distribute and solve the proportion. So 6 times 2 is 12x plus 48 equals 9 times 10, which is 90. Now subtract 48 from both sides. So 12x equals 42. Divide both sides by 12. 42 divided by 12 is 3.5. So x is 3.5 in this example. Set up this problem in a different way to try and still get that x is 3.5. Now in this example, we're actually using proportional parts in a different way. We're actually looking at the converse of the triangle proportionality theorem. Remember, in the triangle proportionality theorem, we were given that these two lines were parallel, and that meant that we had proportional parts. Notice in the converse, though, we're starting with having proportional parts and proving that those lines are then parallel. So in this triangle, we're given pieces of lines. Notice that we're given different information. In this one, we're given that EH is 5, LG is 12, FL is 6, and that EG is 15. So we know this entire segment is 15. We want to determine whether HL will be parallel to EF. And we're going to do that by proving that those pieces that were given are proportional. So we have the part EH, which was 5, over the whole, which is 15. So we have that part over the whole. So I'm going to need the other part that matches with that over the whole on this side. So that's going to match with 6 over. Now the entire whole on this side is 18. So I'm going to have 6 over 18. We know if we were to test those cross products, we would have 6 times 15 and 5 times 18. So 18 times 5 is 90. 6 times 15 is 90. Because those cross products are equal, we know those pieces are proportional. So because we have proportional parts, because the parts are proportional, we know that HL is going to be parallel to EF. So we've proven that those two are parallel. So again, we're going to try and prove that this segment here, DE, is parallel to CB. We do that by proving that those pieces are proportional. What it's asking us to do, though, is find the value of x that will make that happen. So we're solving for it as if they were parallel. So we know AC is going to be 30. We know AE is 22. We know AD is 10. And EB is x plus 4. So I'm going to set up a proportion for the parts that's going to help me solve this. So I could relate piece to piece. So CD to DA and AE to EB. Now what I would have to do first, though, is solve for CD. I don't have that piece. I wasn't given it. But I was given the whole CA and the piece AD. So I could solve for that and get 20. So now I can set up my proportion and have 10 over 20 equal to 22 over x plus 4. Now I'm solving this proportion, so 10x plus 40 equals 20 times 22, which is 440. Subtract 40 from both sides, and I get 10x equals 400. Divide by 10, and x is 40. So the value of x that would make those parallel is 40. In this example, we're looking at the triangle midsegment theorem. This is the theorem that states when we have that parallel segment again, and it cuts the parts so that these pieces are congruent. So this point right here would be the midpoint of the segment because those two parts are congruent, and it shows that by those dashes. It's also going to be the midpoint of this side because those two pieces are congruent. Now what happens is the pieces on the sides are going to be congruent, but the two bases actually have a different relationship. They have a 2-to-1 relationship. This piece 4x minus 5 is going to be half of x plus 11. That means it's going to take 2 of these to equal x plus 11. So I would set that equation up to solve for x by saying I need 2 4x minus 5s to equal x plus 11. And then solve that resulting equation. So distribute 2, so have 8x minus 10 equals x plus 11. And then subtract x from both sides and add 10 and get 7x equals 21. So x equals 3. To solve for y, we know these pieces are congruent, so set those equal. So you guys go ahead and solve for y, and then try example 8. And we'll look at example 8 tomorrow in class.